Okay, so great thing about this, just to finish up this section, we've actually already done this. But I want to hit it more thoroughly because it's an important standard. So let's just fill these in. So take a minute for me. Go ahead and fill these in. Sine, this is just ratios. Just ratios. So here, I'll do sine of x for you, and then maybe you can finish up the other three. So starting at A, if I do sine of x, this is my hypotenuse. This is my opposite from x, and then this is the adjacent. And so I say, well, sine is opposite over hypotenuse, and that must have 3, right? 3 over why don't you just write down the other ratios? Take a minute. Write down the other ratios. Just something you're still working on. I don't want to take too much time on this, though. Cosine adjacent over hypotenuse. Starting at x there still. Then you got to switch and come up here, right, for y. I could have also called it c. The x1 is a. And these will switch then. So this is now opposite. And this is adjacent. So now sine of y is opposite over hypotenuse, and cosine of y adjacent over hypotenuse. And we've already seen this before, but I wanted to hit it. There's two things in this section I want to hit. Sine of y up here is equivalent to doing cosine from the other angle. Right? I don't think I've had any quiz questions on that yet, but I definitely will on the test. So this is an important concept to know. Sine of one angle is equal to cosine of the other angle. How about this? Do you remember this? That if this is x, what's another way to say this angle? That has x in it. This is the one I think you asked about. 90, yeah, 90 minus x. I think I'm going to, I say that moving on here in a second, yeah. But, so this summarizes this section, right? First of all, sine of the angle equals cosine of this angle. Sine of A, cosine of y. Sine of x, cosine of y. The second thing is that the angle measures themselves. So I'm not looking at sine or cosine. But I'm just saying the angles inside themselves, x and y, must sum to be 90. And so if I solve for y, I subtract x from both sides. So another way to say y is I could put 90 minus x in place. All right, that's the other thing they want you to notice. So I'm going to hit on that in a second. So I said that sine of A was cosine of C. Sine of one angle equals cosine of the other. So try this on your calculator. I just want to show you. If I had a right triangle and I had this angle was 65, the other angle when I subtract from 90 would be 25. So just try this out real quick. Verify. Do sine of 65 in your calculator and do cosine of 25. We've seen it as ratios, but I just want to show you, like if they gave you this, they might not tell you much more, but guys, if they say this, that implies it's a right triangle, right? Sine, cosine, and tangent have to be a right triangle. 65 means one of the angles here, 65. So they could say like sine of 65. What's equivalent to sine of 65? And you'd have to say, well, I know that the other angle must be 25, and cosine of that would be equivalent. So I've had questions like that before, and students are like guessing and just trying to put numbers. Well, you got to just think it's a right triangle at 65. I just gave you another one. You don't have to do it, but I mean, same thing, right? sine of 1 degree and cosine. They're the same. So you know that the angles inside sum to 90, but the sine of one angle is equal to cosine of the other. There's two different things going on there. The angle measures sum to 90. The sine of one angle is equal to cosine of the other. That sums up this section. Oh, and right here I just said, well, sometimes it's not x, sometimes it's theta. So this would be 90 minus theta. So then, same thing. If I then say, all right, sine of theta, this angle, that would be equal to cosine of the other angle, 90 minus theta. It's just an odd way for them to say it, but it's true. Sine of one angle, cosine of the other are equal. Let's try a quick example. I'm not going to do all of these below, but I'm going to do, I think, 3 of them. Okay, so let's move on. Any thoughts on those, though? I think I might do 4 of them, actually. So number 1, find the value of x that makes each statement true. Cosine of 34 equals sine of something. So if you look at this, that implies it's a right triangle. It implies that one of the angles is 34. Cosine of 34 will be equivalent to sine of whatever this angle is. Yeah, and just so you subtract this from 90, and it'll be 56. So you could reason through that. Now the other thing that we did here, guys, is we said 34 plus x must equal 90. That's kind of what we subtracted 34 from 90. Let me do one more of these. Let's just do so this one they both have x in them. Let's just do 2. That's fine. Sine of one angle, x, is equal to cosine of my other angle. Now they're telling us it's x plus 10. They're basically telling us the other angle. Sine here and cosine there. Well, the angle, so we're using both of these properties today. Sine of one angle equals cosine of the other. Well, this is referring to the angle measures, though, so these two must sum to be 90. So, number 1, you can kind of just reason through it here. And even on 2, you could, this is what I was saying, sometimes you can do a guess and check. Like plug in a number here, and then add 10 to it and see if they're equal. Well, and that's fine. I'm just showing you an equation way to do it. Right, add those, subtract 10, and get 2x equals 80 and divide by 2. And so that makes sense. Sine of 40, then 40 plus 10, that would be cosine of 50. And those will be equal. Okay, let's skip 3 and jump to the bottom 2. Anything I can answer on 1 or 2, though? Let's jump to the bottom 2. Okay. This was basically an exact question. State test question. I changed it slightly, but the concept is the same. One of the released questions. Sine of x equals cosine of y. Okay, it's really the same as the ones we just did. So they're saying one of the angles is x, one is y. Sine here and cosine here are equal. Write a relationship for y in terms of x. And so all they want you to do is say, well, x and y are the angle measures. They're actually inside. We've used 90, so x and y together must equal 90. This is going to be the same as the 90 minus theta thing. So x plus y equals 90. What is x then? You just subtract y. And it would be 90 minus 1.
This is y. This is just y
Oh, all right. Well, sorry. Let's just switch. didn't matter for either one, 90 minus x or 90 minus y. So, but thank you, good simplifying. Still just hammering home that same idea that sine of one angle equals cosine of the other, but the angles themselves sum to 90. Okay, last thing. Let's do the last one, finish up. Right triangle JKL. I'm going to draw a picture. Angle L is the right angle. Doesn't matter where I put the other two, so I'll just do it like that. Angle J is the complement of angle K. I don't think they actually really had to tell us that. Because if that's a right angle, it's a right triangle. We kind of already knew J and K complementary, sum would be 90. Write an equation that relates the sine and cosine of angles J and K. And so, I know sine of one angle, that's a sine. Sine of J equals cosine K. You also could have said sine of K equals cosine J. Some of that a little bit repetitive, but the ideas are twofold. The sine of one angle equals cosine of the other, and then the angles inside sum of 90. Anything I can answer on that? Thoughts, questions? Okay.